Suppose you have $7,500 to invest for 6 years. The rate that's offered is 4.3%, but you do have some options in compounding. It may be compounded quarterly, or monthly, or continuously. So, first of all, let's think about what would we use to find future value compounded quarterly. We know that our future value formula looks like this, where the accumulated amount equals the principal times the quantity 1 plus the ratio of the rate divided by the number of times it's compounded, and that quantity is raised to the nth power. So for part A, we're looking for the future value. The principal is $7,500. Our rate is 4.3%. Remember to always write your rate as a decimal. So that is 0.043. And you can find that by dividing 4.3 by 100. That's divided by how often it is compounded. And in part A, it is compounded quarterly. So that means 4 times per year. It's raised to the power of 4 times the number of years, which is 6. I put that in my graphing calculator, just the way that it's written. And I have 7,500, open parenthesis, 1 plus my rate, 0.043, divided by the number of times it's compounded, that's 4. Be sure and close your parenthesis, raise it to a power, and since I'm going to do the calculation inside the exponent, I'm going to put it in parentheses, 4 times 6, and also close that parentheses. That gives me $9,694, and we're going to round it to hundreds. So that would be $9,694 and 18 cents. $94.18 if it's compounded quarterly. Well, now what happens to that amount if it's compounded monthly? So again, we have 7,500, and it's 1 plus, our rate stays the same. But now, how many times is compounded per year changes. So in this one, my n is equal to 12. Monthly means it's compounded 12 times a year. That also changes your exponent. So your exponent now is the product of 12 times 6. When I put that into my graphing calculator, the same way that I did before, I get $9,703.07. The final one says, what if it's compounded continuously? Now, we can use the first formula and do 365 days a year, but that's not exactly the same as compounding continuously, which essentially would be 24/7. And we have a different formula for that. If it's compounded continuously, that accumulated amount, or that future value, is equal to our principal times E raised to the RT power. So our principal is still 7,500, and we have E raised to the, I'm going to put this in parentheses because now I'm using my rate, 0.043 times my time, which is still 6 years. Multiply those two together. Let me show you what that looks like in the graphing calculator. So I have 7,500, and my e to the x key is a second button of the natural logarithm. I don't know that you can see the little bitty e to the x. My graphing calculator isn't up can't get it up far enough for you to see, but on your graphing calculator, it's an e to the x, so a second e to the x. There's my e, and I'm going to put in here in parentheses 0.043 times 6, close my parentheses, and if it is compounded continuously, it is $9,707.54. So two things to consider. Well, many things to consider. First, you have to determine which formula you're going to use. You have to be very careful with your variables. What is the rate? What is the compounding? How often is it being compounded? Remember to put your rates in decimal form and to always round those answers to the penny.